Okay, so this isn't going to be the most exciting thing in the world, but I just thought you guys might get a kick out of how I was going to go about solving this particular job. The customer has this as a sample, and he wants stainless steel discs made up replicating that shape, and instead of that integral sort of compression fitting, he then wants these 316 stainless pipe couplings just passed through a hole in the disc and then TIG welded with the disc at approximately that sort of altitude. So all we have to do is make the discs easy peasy, 6 of them, 1/8 inch thick, 2 inch on the OD, with little countersunk holes. And so I was just about to cut one of these little biscuits off, so to speak, and I realized, hey, work smart, not harder. So there's the piece of material that we're going to be taking these parts out of, and we're only going to be taking a couple inches out of the end of it. And sure, we would be able to hold on to this much easier if we would just cut this at some interval, but I want to step up to the challenge of not unnecessarily cutting this bar short, only for a matter of pride. So we're going to hold it in this chuck. So there we've got it set up. We've got it in the chuck, with the chuck held down to the table with one clamp, and then this chunk of angle iron and the studs into the T-slots on the front of the table. And then we don't have to trim our round stock to end drill it. We've just centered up the spindle with the coaxial indicator, and of course to reach over there we swung the overarm to one side and then extended it out a little bit. So that's the whole point of having an amazing Bridgeport, or in this case identified as a Bridgeport. I've probably mentioned it before, but I'll mention it again. This mill has a NT30 taper, which then I can put this collet chuck adapter in there, and this of course uses OZ25 collets. I didn't buy it, it was here when I got to the shop. So I wish it was something like ER40, or better yet, I actually wish that this mill was R8, like a Bridgeport. And of course, you know, we got our drill bit here that we want to use, and we go to our selection of collets, and sure as can be, we don't have the right collet for it. So yeah, if you're ever picking up one of these mills, consider the ability to put collets directly into the spindle. That would be so handy. And also which collets you can get the most sizes for. So now that we're centered up on the part, or the new material, it's always so tempting, it's the forbidden fruit, to then just walk the spindle over to a hole and pick up the bolt circle that way. And it works sometimes, but just not all the time enough to be a disaster when you do get sucked into it. So I would be a strong advocate of measuring across and then doing the math, which I believe is that distance divided by 2 divided by the cosine of 30, and then multiply the result by 2, right? Right. Okay, we got the bolt circle in. Let's see if it actually is the right one. 3 drill bits all the same size. And there's the part. And all right. Can't beat that. And there we are. We made one so far. Makes a bit of a racket while it's cutting through those past those holes for the interrupted cut, but we're just gonna knock that little chunk off there, and it's pretty much it's done, we can give it to the welder. Oh yeah, we got to put those countersinks in. Well, there we are, 6 of them all done with the little countersinks in them, and they're nice, really snug fit on the pipe coupling there. So unfortunately it's kind of scuffed up a wee bit where the parting tool was running by the interrupted cut, but that's just fine because there'll be a bunch of paint go on there and hide everything once it's installed anyway. So c'est la vie. Thought it would be a little bit nicer, but that'll as we've said before, plenty good enough.